Hi to everyone, this is Dr. VNSR Venkateswara Rao from the Chemistry Department, working as Associate Professor in Institute of Aeronautical Engineering, Hyderabad, 543. So today I would like to give the topic on the types of the plastics, mainly thermoplastics and thermosetting plastics. So now let us see what are the contents involved in the today's topic. So mainly, first of all, we define the what is the plastics. After that, we see types of the plastics and advantages. So then classification of the plastics, nothing but thermoplastics and thermosetting plastics. So now let us see first of all what is the basic definition of the plastics. Plastics nothing but the substance that can be easily formed or molded into a desired shape. So basically, plastic is one of the best polymer, and it will be molded into required shape by applying the temperature. So that is nothing but a plastics. So according to definition, plastic is a substance. Substance nothing but it is the category of the polymer, and that can be easily formed. That means easily prepared or molded. Molded means we can require so many shapes. By taking example of the toys, they are presented so many shapes in order to attract the kids. Whether they attract the games. So depends upon that the plastics are molded into required shape. So plastic having the nature, they can be molded into our required shape. Okay, so that is nothing but a desired shape. And plastic can be formed in a desired shape by the effect of a mechanical force or heat. That means by applying a pressure, that is nothing but a mechanical force, or by applying physical properties. Physical properties nothing but a heat. That means by applying temperature, we can molded the plastics into desired shape. Or if it is possible by applying pressure, nothing but a mechanical force that can be and that can be molded into required shape. So, in the manufacture of plastic, raw materials like coal, petroleum, cellulose, salt, sulfur, limestone, air, water, so many compounds are used. That means in the plastic raw materials, especially used for the coal. Coal is nothing but a fossil fuels, and petrol is also one of the fossil fuels. After that, cellulose is nothing but a carbohydrate. After that, salt nothing but a electrolyte. So then go for sulfur. So sulfur is coming out from the oxygen family: oxygen, sulfur, selenium, tellurium, polonium. So all of these belongs to a sixth group of the family periodic table. So that is nothing but a oxygen family. So after that we see the limestone. What is the formula for limestone? Calcium carbonate. Calcium carbonate. After that we see the common solvent and best solvent, nothing but a water, and it is having a formula H2O. So almost all these fossil fuels, carbohydrates, electrolytes, and oxygen family compounds. After that we see the calcium carbonate, including the common solvent, are included for the manufacturing of the plastics. Okay, so this is about the manufacturing of a plastics with its definition. So after that we see what are the advantages of a plastics. So compared to other materials, why you prefer the plastics compared to other materials, why you can give the importance towards the plastics. So that is nothing but the advantages of a plastics. Let us see what are the advantages of a plastics. The first one is nothing but a low fabrication cost, low thermal and electrical conductivities, high resistance to corrosion and solvents. So first one, low fabrication cost. Fabrication is nothing but a manufacturing of the material. Compared to other materials, the plastic having a cheap in cost. Why? Because they can prepare very easily. Already we said in the definition, plastic is a substance that can be easily formed, or molded into a desired shape. So based on the definition, first of all, it is having a low fabrication cost. After that, we see low thermal and electrical conductivities. So, compared to metals like copper having a highly conductive element, but plastic is very low conductive and very low thermal conductivity. So, in this case, what is the conductivity? Conductivity is nothing but a reciprocal of the resistance. So, it is formed by the mobility of the ions. So, and it is high resistant to corrosion and solvents. So, for example, if you can consider the iron material, that can be easily undergoes corrosion in the presence of a environment. But whereas in the case of the plastic, there is no such type of the reactions that takes place. So plastic is a inert to the environment and atmosphere. and some of the elements in the presence of a hydrochloric acid. For example, it is a best solvent in the presence of hydrochloric acid. So many elements undergo say acidic corrosion. But whereas in the case of the plastics, there is no such type of the corrosion, and it is inert to and plastic is inert to the so many solvents. So that's why high resistance to corrosion and solvents. So after that we see the stress and strain relationship of the plastics is similar to that of the metals. So even though before coming up of the plastics, most probably we use the preference gives to metals. Why you can give the preference to the metals? Because the stress and strain relationship is very better in the case of the metals. So same such type of the relation, that means stress and stress and strain. That means we can apply the excess pressure. They can be molded into required shape or desired shape. So such type of the nature will also observed in the plastics. So that's why the stress and strain relationship of the plastics is almost coincidence with the metal properties. So plastics reduce the noise and vibration in machines, whereas in the case of the metals they produces the so many noise and vibration in the industrial process like machines. But whereas in the case of plastics, they can replace with those elements which can produce the high noise and vibrations in machines, that can be replaced by plastics, and you can reduce the amount of the noise and vibration present in the machines. Finally, plastics are the bad conductors of heat, are useful for making handles, used for hot objects. Most plastics are the inflammable. So, PPT just sit, sir. So plastics are the bad conductors of heat, useful for making handles, used for the hot objects. Most plastics are the inflammable. That means, whereas in the case of the by taking elements like copper, iron, those elements are the good conductors of the electricity. But plastics can be acts as a bad conductors of the electricity, and they are useful for the making handles, used for hot objects. For example, we can take as cookers like that. In the handles of the cooker we use the material of the plastics to avoid the that heat circumstances and heat environment or heat situation. So most plastics are the inflammable materials. Most plastics are the inflammable materials. Okay, so next we see advantages some more. So that is nothing but a plastics are the electrical insulators and find large scale use in electrical industry. That means even though the plastics are insulators to the electricity, but they are used in electrical industry. Why? Because the electrical goods are handled with the plastic to avoid the shock circuits or shock treatments. So plastics are the resistance to the chemicals. So that means by adding the either acid or either acid. So by adding the either acid or alkali, plastics should not react with the corresponding solvents. They can undergo their own reaction. And plastics are clear and transparent, so they can be given beautiful colors. That means while compared to the other metals, the plastics exhibits so many colors, especially from the spectrum like VNSR, violet, indigo, blue, green, yellow, orange. Almost all the colors exhibit by the plastics, and they are very clear. That means transparent, so they can be given beautiful colors, and appearance is very good. Okay, and after that we see the types of the plastics. So the types of the plastics mainly classified into two types: thermoplastics and thermosetting plastics. From the title we can understand first one is the thermoplastics. So thermoplastics means, from the title, the plastics are molded. These plastics are molded by temperature into a desired shape. That means the plastics are soft on heating and stiff on cooling. The plastics are exhibits the properties like soft on heating and stiff on cooling. That means these are produced by the additional polymerization. So additional polymerization especially observed in the case of the polythene and polyvinyl chloride. That means when the monomer of polythene like ethylene undergoes the additional polymerization to give polythene. And the monomer of the PVC, nothing but vinyl chloride, undergoes polymerization to give polyvinyl chloride. So see the reaction like ethylene. CH2 CH2 N moles undergoes addition polymerization to give polythene. So this is the example for a additional polymerization polythene. Like that, we observe the polyvinyl chloride also. So polyvinyl chloride, nothing but one hydrogen can be replaced by the chlorine atom. That means CH2 double bond CHCl undergoes additional polymerization to give polyvinyl chloride. Okay, so these two are the best examples for the additional polymerization. So such type of the additional polymerization observed in the case of the thermoplastics. So just remember the definition of the thermoplastics. That means the plastics are soft on heating and stiff on cooling. So those plastics are nothing but a thermoplastics. So the regions are made of long chains attached by the weak van der Waals force of the attraction. Why? Because these are soft on heating and stiff on cooling because of the weak van der Waals forces. Weak van der Waals forces of the attraction are observed in the case of the resins present in the thermoplastics. So on heating, they are soft and on cooling become stiff. That means from the definition we can understand on heating they become softened, but on cooling they become stiff. That means chemical changer want to change and they can be remolded. They can be remolded. That means once they can shape it into desired shape, if you can modify or change its shape, and it is possible in the case of the thermoplastics. Such a type of the nature is nothing but a remolded. Remolded. That means we want to change the shape uh, based on the intermolecular forces of the thermoplastics. Mainly the intermolecular forces in the thermoplastics is nothing but a van der Waals weak forces. That's why they are softened on heating and stiff on cooling, and it is possible to they can change with our other shape. That means from desired shape to any other alternative shape. So such process is nothing but a remolded. So after that we see scrap waste product can be used. Waste product can be used in the case of the thermoplastics. That's why they are very cheap in cost. So and what are the other properties of the thermoplastics? That means the resins are soft, weak, and less brittle. That means because of the involvement of the weak van der Waals forces, they are very soft in nature, and with respect to strength, they are in weak. After that, we see the very less brittle nature. Brittle means breaking. So they are usually easily these are easily soluble in some organic substances because of the weakening in bonding. They are easily soluble in the organic solvents. And what are the examples of the thermoplastics? Already we discussed about the additional polymerization occurred in the case of the thermoplastics from the first point. So for the additional polymerization, the best example of the polymers is nothing but a polythene and polyvinyl chloride. So the monomer of the polythene is nothing but ethylene, and the monomer of the PVC, full form of PVC is polyvinyl chloride, and monomer is the VC. VC is nothing but a vinyl chloride. Contain long chain polymer with no cross linkage. That means we observe only linear chain and branched chains present in the thermoplastics, but there is no cross linkage. So with respect to absence of the cross linkage in thermoplastics, the strength of the polymers is very less. So based on the chain, the type of the chain involved in the polymerization, we can explain the stability of the polymers. If it involves the linear chain or branched chain, the stability should be either low or medium. But but the polymers involved cross-linked chain, they are highly stable in nature. So after that, we see the thermosetting plastics. So from the title, we can understand once we apply the temperature towards that plastics, they are the thermodynamically setting plastics. But even though once they can fix its shape, after that we cannot change its shape individually. So that is nothing but the thermosetting plastics. That means these are produced by the condensation. These are produced by the condensation polymerization. So what are the other polymers produced by the condensation polymerization? Nothing but nylon 6,6. They are highly stable. So the resins have the three-dimensional network structure connected bonds. That means the resins have the three-dimensional. The resins have the three-dimensional cross-linked structure. That means we observe the x-axis, y-axis, and z-axis. So this is nothing but a three-dimensional network. So because of these three-dimensional networks, the polymer gets the high stability. On heating, they become stiff and hard. No change on cooling. So this is very, very important. On heating, they become stiff and hard. On heating, they become stiff and hard. And further, there is no change. And further, there is no change on cooling. So this is nothing but thermosetting plastics. So from the title, you can understand on heating, they become stiff and hard. But further on cooling, they can change their individual shape. So chemical nature and also changes. That means they cannot be remolded because once set means they are permanently setting polymers. So the molding is possible. That's why we use it in word remolded in the case of the thermoplastics. But whereas in the case of the thermosetting plastics, once we heat, they can be stiff and hard, and further there is no change on cooling. That means there is no possibility of the remolding, and scrap cannot be used in the case of the thermosetting plastics. But whereas in the case of the thermoplastics, we use scrap material for the preparation of the various goods. So after that, we see the thermosetting plastics, some other properties. The resins are usually hard, strong, tough, and more brittle. So the resins are usually hard material and strong, tough material. After that, we see the more brittle nature. So resins are not soluble in the organic solvents. But whereas in the case of thermosetting plastics, because of the weakening bond, they are soluble in organic solvents. So what are the examples of the thermosetting plastics? Nothing but nylon and bakelite. So because they involve the cross linkage, that means they have 3D network structure. So 3D network means they are involved with the cross linked structure. So generally we see linear means the monomers having the only left and right bonds. So this is the linear chain. But whereas in the case of the branched chain polymers, branched chain polymers means we observe the branch either top position or bottom position. So these are having the low stability and these are having the medium stability, and final one is nothing but a cross-linked polymers. And final one is nothing but a cross-linked polymers. So cross-linked polymers means we observe the totally up and down bonds. Up and down bonds. Okay, so because of this cross link and it can satisfy the four sides of the bonds, they are having highly stable. So such a nature is nothing but a cross linked structure or a 3D network structure. 3D network structure. Okay, so this is about the thermosetting plastics. So these are nothing but the types of the plastics. Okay, thank you.
Like, share, and subscribe. Hit the bell icon for more updates.